In this problem, it asks for it mentions parametric equations. So the example that I worked out with a lot of you in class when you were asking about this was, imagine that I said I'm going to define x in terms of a new variable theta, and I'm going to define y in terms of the same variable theta. So then if you had to graph whatever this ends up being, you can define things in terms of theta and then determine what x and y are. So like if theta is 0, then x ends up being 1 because cosine of 0 is 1 and sine of 0 is 0. And so then you can plot this point. And if x is 30, you can figure out what coordinate you get. And if x is 60, you can figure out what you get. And if x is 62, you can figure out what you get. And you can just keep going on and on and on with that, and you get a whole bunch of points. And you plot all those points for this example. Remember, cosine theta and sine theta, that represents any point on the unit circle. So if you plot all the different thetas, you're going to get the unit circle. So this set of parametric equations represents a circle centered at 0, 0 with radius equaling 1. Then what I did was I took the same thing and here, let me paste that over here. And I just said, okay, what happens if I do this? So now this thing represents a circle centered still at 0, 0, but the radius is now 2. And then I did one more example. So if x equals, let's say it's 2 cosine theta, y is 2 sine theta, but I increase the x's by 4 and the y's by 1. So now all that means is I took the same exact circle that I had before, and the x values moved over 4 and up 1. Well, that means that the center moved over 4 and up 1. So the center is now at 4, 1, and it's a circle still. And the radius is still 2. So these are the important ideas. So if we go back and we look at 7a, well, that's really just a circle centered at 0, 0 with radius 3. And then this one right here is going to be a circle centered at 7, negative 2 with radius equaling 3. So this is part A, this is part B.